Yeah, let's see. Yeah, my toggle for my camera doesn't work. I shouldn't have pressed the button. So as soon as I clicked on Hydra in the virtual machine, it crashed. All my screens, all three, became black for a bit, and OBS crashed. So let's see. Studio mode, camera. There. And let's. Yeah, so I've been saying I should reinstall my computer, but I've also been saying that I should get a new one, and then I don't have to reinstall it. You know. So this is a test now to see what will happen. Look at this window. It has white edges. It's definitely like stuff happened, right? This is kind of buggy. So I'm closing Firefox. Also, I did close down the TTS, since it's actually another program. So, and also in YouTube, this will be a totally new stream, because that's how YouTube works, and it's buggy, right? Well, I think that's buggy. So I'm starting the TTS again.
Connected to channel fix at 42.
Hello there, TTS. Starting. Yeah, start voice recognition. I'm starting Firefox again. And Firefox require a lot of resources. I also had my notes up. And I closed that one too. I don't think it requires a lot of resources though. So it actually crashed twice when I started it again, OBS, and the second time it said browser source. I started it in safe mode, no plugins, closed it and started it again, because I'm using it, a plugin to dual stream, right, to YouTube and Twitch. So that's why I need that. And Firefox says it's been updated. So anything could have really done this, right? To believe it was Hydra's fault? What do you think? I'm kind of thinking Firefox is always all these tabs, you know. Actually, let's. So I found this old video where someone sent me a link. Let's see, let's make a new folder here. 7. And let's just add all the things here. And this is the one that I was talking about. Ancient video. So it was a bit. Yeah, so let's actually delete everything that's older than. So it's nice to have the TryHackMe still, alright? So let's close these. 46 tabs. And we don't need to TryHackMe either. That's the path. This should be the room. So we need to have this up. I added an hour just now. We have all these saved now, including the ones I got now from you guys. Including all of this thing. Yeah, so we're doing something different now, so we can just open these after stream. I'll just keep this one up. And let's just quickly check the task manager. So, and also what are you seeing? What window? Right, you're looking over there. So I thought you were looking at this screen. So let's see here. So, poor CPU. But I don't think the CPU will crash like that. I always suspect my memory. And now after closing all of these things, we're still at... Well... No, we should have more. We should have more. I'll have to check my OBS settings later because, you know, if I can use my GPU more, that might be good. And a new computer. I bought this secondhand from someone. And it's never been perfect, you know. For a long time, I had problems with it. Every time I remove power, it like loses all settings. First of all, and then it has been like taking minutes to start, though it's, you know, freshly installed. All the settings in the BIOS reset everything. So it's a bit of funny stuff. And now it's never late at the boot again. So logic, no. So maybe I should buy a new computer that I have full control over from the start. So you can undo and redo using the curved arrows. Oh. So I did double click this file. I don't know exactly where you disappeared, but I know when all my 3 screens got black, and that was just when I clicked the button to analyze. Maybe I should have my task manager up. So it'll be interesting to see, you know. So if we look what's actually doing something, if we go for memory, OBS is like the crazy thing here, right? Why so much memory? That's a lot of memory. And CPU, it's also this. Yeah, so if we click just for name again, it sorts. We said VMware, it's really not that much, right? This is like, what, seriously, right? Seriously? No, that can't be right. Is it using 11 megabytes? And Chrome, who's doing the TDS, and OBS. So Chrome is currently at maximum of the CPU values. What? So I'll just click it again. So we have the TTS up, but I also have, it's running an ad on Twitch, which is kind of funny. I have it up there to see that the stream got back up. and it's frozen. It's frozen, so if I close the Twitch tab now, let's see. That's not a lot of memory. So I had also YouTube one up to test. Closing that one down. Also not a lot. So we're still, this is only the TTS. This is the only thing running in Chrome. Right? What is Chrome doing with 22% processor? Because all this does, I mean, there's nothing in chat. It's listening to me. So if we stop the voice recognition, it should drop down a lot, right? Yeah, so now it's just disappeared. So it's the voice recognition that takes all of this. So if we enable voice recognition again, so it's still only sending this on. It's not working on it itself, right? Yeah, this is heavy. So I didn't usually use this. I just started because it didn't work before, now it worked again. Well. So anyway, we found what the reason was. It was the voice recognition. So I'm now reopening the closed tabs. No, don't I have another one? Oh, let's put this back here. So Chrome is back up on the high numbers. When I moved it. So when I move Chrome, then we're getting more. So it's working when it's moving. Okay. So it's opened YouTube. It's at, well, 3 still. So if we undo another one? Undo another close tab. So I just went to the history and got one of these up. And now we're at 8. So these they're taking in percentage, it's kind of heavy still, right? But if we start the voice recognition, let's see if we get up to 22 again. Because I think 22, 23, we were in a 23 point something there. I don't think this is too expensive in cost. So let's kill that one again. So let's see. Moving this out of the way. It's just there to, I have it on my third screen, and then I have OBS over it here, so this is what OBS looks like. So it's at 15%, though I'm moving it now. We have both chats there. The audio. So let's have this up while I start. It's actually started it already. Yeah. So do you remember how high the percentage of the processor was a bit ago? Very interesting this. So let's get the apps up here again. And I'm curious if all the VMware resources are actually here, right? 11 megabytes. I mean, it's not like, you know, it's just compared to OBS. Oh, I'm sorry. Oh, I have the demo program on. I can't see it underneath there. So this is the speaker box, TTS for Google, for YouTube. And then we have demo, whatever it's called, demo. We don't need that one. So, and maybe I should uninstall Japanese, right? NVIDIA stuff. A lot of browser pages here. So probably too many. Probably a lot of these I could go through and remove. They're not taking a lot, but like collected a lot of them, that would take in a lot of resources. Steam, why would that be on? Oh, I have no idea. I never have that on. I didn't restart my computer, and I started something and just closed it down at once yesterday. Right, yeah. So that's why. This is what gives the camera. It's the web app of my Sony camera. Webcam of the Sony camera. It's an app in the computer. And it's a USB from the camera to the computer. So, all the stuff, I guess will continue. That was very unexpected. Very unexpected. Though I should always have like no tabs open in my Firefox, I know that. Right, so it did find the full undefined 8. Oh, so we're not interested in this bit, we're interested in only this, what it actually is, right? So we want machine code translated into assembler. That's what we wanted now. And there's so much else here, you know. I guess it's like it says there's ELF section headers. So I would need to know more about the ELF format. So it says SHT, and my brain reads this as shit for everything. It sounds so unprofessional to have this here. Well, how would your brain read that, right? They're all called shit init array and stuff like that here. Sorry. Am I getting tired? Maybe. So, to get to the actual start of the file, it's ELF64 EHDR. Let's see, we saw something more there. Pop up again. So, it's timed. ident magic num, ident magic string, class data version, OS ABI version, pad, typing version, empty, pof. So the string is ELF. Yeah, so 74454C, it's what's up here, 46, and so on. So this is like the start of an ELF file then. And start here, entry. So if I double click this, I'm assuming we'll hop over to the code. Entry start. So if I click something here, will it... Also, where is the actual... So look, it changed one here. It's not the main. Here's the main. So it didn't hop to main. I'm doing that again. So start is not main. Start is something else that does stuff and then hops to main. Yeah, I guess that's logical. EBP, EBP. XOR with itself. Okay, so it's zeroing it. So that's like this. Now we're starting something new. Whatever. RDX R9. Yeah, so I need to check what's before there first too if I wanted to check that out. Let's hop to the main then. So 2 seconds. I'll just go quick bathroom break. There. So I'm seriously thinking, should I not stream to YouTube too? Should I stream to YouTube too? Hello. So let's check here. First is this one is live, right? Yes. Let's do a test.
Fixit says, test.
Yeah, I could hear that. And then I do on YouTube. So this should also be red. So let's restart SpeakerBot. So test again. So it says that it's initialized and everything. Testing. Right. Do you know what crashed? StreamerBot crashed, and then it won't do it, even if it started. Because StreamerBot is what tells it. So I missed that StreamerBot crashed. There. Or did I close it? So now, fourth test on YouTube.
Fixit42 live says test.
Yeah, so now we have TTS on YouTube too. Sorry about that. Yeah, so now we can continue here. Also, I'm curious, it says undefined, but because it doesn't know. Right. Anyway, we have 55. Have we not seen a lot of 55s? So when I do this, it doesn't hop back to the normal place when I go too far away, which is annoying. I usually use that to hop back to where I was, right? So type machine version entry POF flags e-size, whatever this stuff is, right? Program head. Let's change program header table and initial ELF program interpreter. Okay, it's the Linux x86-64 SO2. And all these SHTs makes me... I must be tired, right? ELF section headers. So, is this like dotted and doesn't have an end? So let's see, this is the longest, because this disappears, right? So, when I click this, nothing pops up here. We get a tiny thing here. Yeah, I need to know more about ELF executables, apparently, right? And then we have nothing. I don't like not knowing stuff. I want to know it all. in it. What stuff happens when we right click? Colors. Show references. This is actually what I was looking for. So this is here. Hmm. What does DQ means? Define constant quad word in program memory and EEPROM. Mm-hmm. Yeah, so I sorry for not switching screens. I just googled for DQ x86 because curious. I just put x86 because I got some random page on DQ. So define quad word. That's the odd thing, right? Now I want to go back. Where did it say pink? P-adder. Smells line. Yeah, so let's actually focus on I think we can do functions or something, right? Main. So this is our actual code that we make. So can you like run stuff here? That would be nice if you could like step through things in this level and see what actually happens. Right? What can you do this thing? I haven't seen such a thing before, but processor manual. Nice. So we have to see what this says. Could not find. Due to copyright issues. It's not included. Location to place the file. Okay. That's nice. Very nice. To have instructions. But not now. So push RBP. We save the RBP we have, and then we put RSP in RBP, and so we have RSP saved in RBP. Oh, something popped up when I hold my mouse here. Why? So we should have one of those other ones off. So let's see, PDFs. If I open Acrobat Reader or whatever it's called, yeah, it's Acrobat Reader still, and I'm thinking it might have like recent files. Assembler. No, not that one. We searched yesterday for something for. Anyway, it was in this too. In this document. Here's the registers. Recent files. Cheat sheet. What was that? Yeah, so I should really read. Let's do this instead. No, it's not good enough. I'm thinking the third file. No. Was it a web page then? I mean, this might be great, but it's not like a list of all the functions. Let's skip that and I just didn't want to open a million tabs again. We just closed a lot of tabs, right? Well, we did put one here on more. Let's click this one, and it's I think it's Coder 64 that we did, maybe. So if you look for Leah here, load effective address. Yeah. have something in my hair that's like there, gone. It was kind of obvious, but I'm thinking, let's do it carefully, right? So, RAX, and this will be the string. Where is it? Let's click it. Here, and here we have the DS. Was it DS? Now I have to go back. No, it was DQ, because this is another one, DS. Should it be then string instead? And Q was quad. Anyway, we can see it here. Yeah, so HELLO exclamation mark null for the string. And it's called sHello. So if we click this one, nothing happens, but if we... No, we don't have that one. Hopping back thingy. What if I do this? Go to previous location. Woohoo. Yes, it did. So, it also says here that it is low, right? So, my arm just generally sometimes didn't like it today, apparently. So, move. So what does this mean? This bit here. Yeah, I'm kind of thinking it's time to put all this. Copy. So let's ChatGPT, so we save a bit of time, right? Please explain the commands. No. So it failed pasting. So what we need to do is to stop it, to edit this, and to copy it again. I failed my copy. 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 Can I paste now? No. So what if I copy special here? Formatted code. I want all of it. Is that formatted code? No. I did copy this several times. If we go to something else in here, then I could copy it. So if I select this and copy it several times, and then I paste it here, now we could do it. The Predator assembler code is part of a function, likely the main of a simple C. Yeah. The section is a header indicating the start of the main function. It shows us this function is referred from 4 different places. Oh, okay, so it's referred from 4 different places. That's interesting. I didn't know that. So 4 different places refer to the main function. So, push the current base pointer to the stack to save the caller's stack frame. Yes. I understood that, and then I understand this. Move the current stack pointer to the base pointer. And this sets up a new stack frame for the called function. REX. This is the one. No, this one I understood to load effective address of string into REX register. Right? Yeah, and here apparently this is the address, which is nice to know there. Here. Yeah, so this I understand. This I don't understand. So just this bit, that this is like an extra explanation. Let's see what it says. Move the value of REX and the address of the string hello to the RDI register. The RDI register is used to pass the first argument to functions in x86-64 calling conventions. So it's because we need to set the that's why. But this format here of Hydra, it's very odd. It's very odd. Anyway, move EAX. Now we could just continue reading because that was the unclear bit, but we can continue reading it here. So 0 to EAX. Typically done to set up for a 0 return value or clear the EAX. So yeah, so we're just empty it. We're just emptying it there, so it's nice and clean. Call external printf. Call the printf function, which prints a string pointed to by the RDI. So it did actually say this. Let's hop back here. So we can close this one. It was just to be able to copy the darn thing. Here, so it says external printf here, right? So it's just calling the function. And then we have another EAX. And we pop the RVP back and return. So this didn't do anything really, right? But by reading it, we have a base, right? So if we were to do something more complicated and look at it the same way, we know more what we see. And it's so warm in here now. I have to go open the window again because I'm like dying. So I have an AC, but it didn't work very well. I think it actually generated more heat by being on than it made cold. So it's just taking a lot of space. So every time I'm going to the window, I have to like go through a whole mess here. Well, I guess we get some gymnastics exercise. I should test run it again. Maybe I should do it now because it's not crazy hot, but it will be noisy, so maybe not again after stream. So we can throw it out if it's bad and actually use it if it's good. So external : printf is how we call, how we see that this was equal here, right?
Black, PC says this is assembly language.
Yeah, let me show you where it comes from. So I made a simple hello world, or just hello here, the C, and then I have opened it with the executable with Hydra to look at what it actually looks like in assembler here. And then I'm thinking we can make a more complicated one and see what that looks like and like learn. So let's actually make a new one now. But I would like to know, we have lots of more code in this. It's a big file. It's huge actually. So this L format for executables, it seems to have so much things in here. And I don't know. It's so much stuff here. So if we click this, we should hop back. And what I learned from this, from sending this bit of text to we could actually do ChatGPT for the whole thing too. Anyway, we know that it's 4 references to this. I didn't think of that. But can we see where the references? Show references to main. So there are 4 references. Well, I'm just starting with the one at the bottom. It's like I'm mostly just looking at the position in the file because most of this is Greek to
Black,
me.
PC says why you are not use C or C++ language.
Yeah, I did use C, but I wanted to see what it actually does. Because the compiler changes it to something else, So the reason is to be able to mess with stuff. Like buffer overflow is what we're currently looking at. So why is it 4 references to this one? Yeah. I'm actually going to see if I can do all of this and copy formatted code. We had last time to just paste it somewhere. So I'm just VAX here. By the way, let's see how long it is. It should be kind of long, right? So let's see if we can send this to ChatGPT. We didn't finish it though. Is there anything else it says here? So no, it's nothing more. What about the parts of the elf? That is not our code. Please explain. And I'm assuming I could send it the binary data, right? But it's also big. So let's see if we can paste this here, and it will say like this was too much. Error generating response. Yeah, something shorter. I was kind of assuming this. So it usually just dies right now. Before it was, you couldn't paste much. It just said this is too long. Now it just breaks. Error generating response is worse than then it's just saying you can't paste this long stuff, right? So this is its response. Where's my question? I could have just typed it again. Yeah, I pasted a long thing. Long thing. Whatever. Let's new here and I made a short hello world program in C to look at in Ghidra. The code, my code is short. Tell me about the rest of the 15K elf file. It's crazy, it's 15K. It's huge. When you compile a short hello world program in C, the resulting elf file is significantly larger than the actual code you wrote. This is due to several factors inherent in the elf format and compilation process. Here's the breakdown, and I should sing my voice a bit, so I'm going to TTS this. Let's do this bit first.
1 elf header. The elf header contains metadata about the file, such as the target architecture, entry point address, and the format of the program header and section header tables. 2 program headers. These headers describe segments of the program to be loaded into memory, including the type, offset, virtual address, physical address, file size, memory size, and permissions. 3 sections. Elf files are divided into sections, each serving a different purpose. .text, this section contains the actual executable code of your hello world program. .data, this section contains initialized global and static variables. .bss, this section holds uninitialized global and static variables, which will be zeroed out by the loader. .rodata, this section contains read-only data, such as string literals like hello world. 4 standard library code. When you compile a C program, especially with functions like printf, the compiler links against the C standard library, libc. Even a simple printf call can pull in a significant amount of code for handling I/O, formatting, and other utilities provided by the standard library. 5 initialization and finalization code. There are routines that need to run before and after your main function. These include setting up the runtime environment, initializing global variables, and handling program termination. These routines are part of the C runtime, CRT, startup files, such as CRT0, CRT1, CRT, and CRTN.
And the rest.
6 symbol table and string table. The symbol table contains information about functions and global variables. The string table holds the names of these symbols. These are used for linking and debugging. 7 debugging information, optional. If you compile your program with debugging information, example with the G flag in GCC, the ELF file will include additional sections containing source code references and variable information to aid in debugging. 8 padding and alignment. To meet alignment requirements of the target architecture, padding bytes are often inserted. This ensures that sections start at addresses aligned to their required boundaries, which can improve performance and is necessary for correct execution. Example breakdown. Here's a hypothetical example breakdown of a small ELF file sections and their sizes. ELF header, 64 bytes. Program headers, 168 bytes, example 3 headers, 56 bytes each. .text, 500 bytes, your actual code. .data, 100 bytes, initialized data. .bss, 50 bytes, uninitialized data. .rodata, 30 bytes, read-only data like strings. Symbol table, 600 bytes. String table, 400 bytes. C runtime startup code, 3000 bytes. Standard library code, 9000 bytes. Padding and alignment, 200 bytes. This is a simplified example, but it illustrates how quickly the size can add up even for a simple program. Exploring ELF in Ghidra. In Ghidra, you can explore these components by opening your ELF file and navigating through the various sections. ELF header, view the initial metadata about the file. Sections, browse the .text, .data, .bss, and .rodata sections to see where different parts of your program and its data reside. Symbols, inspect the symbol table to see all the functions and variables. Disassembly, look at the disassembled code to understand the machine instructions generated from your source code. By examining these elements, you can get a comprehensive understanding of what makes up the rest of your 15K ELF file.
So there's no .txt text here, right? Because let's just look at something here. Yeah, so I can't click a million times oh, there's the text.
Black, PC says, what do you use to convert text to voice?
The TTS that I'm using is made by Security Alive, and it's tts.bot is a web address, and you can connect it to your Twitch channel. So for currently, I'm using SpeakerBot with StreamerBot to do the YouTube one, but hopefully I will use this one for YouTube too. Because sometimes they crash if people speak in at the same time. It's hard to hear if there are several TTSs at once. So right there. So, taking the opportunity to check that everything works as it should. And I want to see my preview in OBS. I can see what you see. So, yesterday I had to stop streaming because I kind of started losing my voice. So, I'm trying not to read. I usually read it all instead. Well, we know a bit more about ELF files, but I still feel that 15K is crazy for a Hello World, right? So, if we go back here and let's look at the code. This is what we have, right? So. And if we compare it to this file, it's actually 16K, right? Though the directories are 4K too. So I'm like, yeah, I wonder how big hard drive does an IBM XT have? Anyway, let's make another file. We can modify this one. What should we add? Should we add? Let's make another function, right? So let's do a yeah. We want to return a value, and let's make another int test, and yeah, we can make an add one, right? So add int a comma int b, right? And we want this one to just return a plus b. I think that should be enough, right? And of course we have to call our function, right? So hello and not tabs. Add. We can have some more text. No? Right. That's right. So we're in Nano. I usually don't do this kind of things in Nano. I just do basic text. I don't know if I can... No. I got the other thing. And I can't undo this. I'm just going to X with a no save. Let's actually edit this in mouse. Just that here. So we'll open it here. That's just a bus. It'll pause. So we'll open. I called it programming, right? Can I type somewhere? Yes, I am not comfortable with this UI stuff. I'm sorry. Here it is. So let's do this again. And add and A, comma and B, and I missed that. And now I can use a tab. No, I can't. It's still not good enough. Just return A plus B. And we have main. We're adding here. Let's actually now copy this line. And let's do A colon, right? No, we don't have to have input. This is just a basic test, right? Let's just run add and let's say what it's supposed to do, right? And I want this basic. So we're going to actually print off this there. I think it can do this, right? We don't have to tell it the formatting. So this is the fun thing with let the compiler tell us if we did anything wrong, right? So add A, B, return A plus B, add, we need to have 1, 2, right? Or we could just let the compiler give us this too. I'm saving that, then we're tabbing back here to compile it. So it tells us a warning. Pointer front integer without a cost. Yeah. File included from expected conchar the script, but type int. Extern int print char restrict format. Yeah. So let's do printf a bit nicer. And do. So anyone who remembers the syntax? I don't know. Something, I don't know. Let's Google it if I'm wrong, right? So it made a new file.
Black, PC says in int main function you cannot be return 0. Why?
Not return 0. in int main function you cannot return 0. So I didn't. Also, the main function is a bit special, so it might be because of that. So it did calculate there for us and everything. Let's add a line break, right? Let's add a line break before we make it a bit prettier. Let's do a backslash n here, and let's add a backslash n here. So I'm not returning anything, but there's error codes and there's special stuff with the main function, so maybe that, but I don't know. We should be able to return 0. Let's return 0. Or just 0. So yeah, I can return 0 if I want to. It works. But we don't have to return, which is kind of funny, right? We have an int function, but we don't return anything. Oh, okay. So my headphone said that it had a low battery. Let's see. So I'm just switching, so this one can charge. So now I have the ones I usually have. They're actually worse because they are like I can't hear all stuff. But those kind of fall out of my ears. Let's go back here, and the purpose for this, right? The purpose for making this file is to open it in Ghidra and see what is the difference, right? I should have really made a new name for it, so we wouldn't have to have such a mess here, right? So what if I close this one and we have still this one open? So let's make a new project again. And hello 2, which I should have called the file, right? And let's import a file. Hello again, because should have renamed it. Actually, before I do this, let's actually rename the file.
Black, PC says in void main you cannot return anything.
Yeah, in void main. Yeah, so I had int main. You can't return anything from a void function. So void means I won't return anything. That's what it means. So if you have a void function, you can't return anything from it. If you change it to int, then you can return something. You can return an int, an integer. So that's why then. CP hello. Hello to LSLA. So we have a hello 2. We can add the other one later, meaning like go back and have the other one too if we want to. It's now open, so we don't confuse this poor program and me by having several things with the same name. So open hello 2 in hello 2. And last time I did this, stream crashed. So this is a good test to see if stream crashes somehow. Ghidra can affect it. Right, so it was actually when I had clicked this and I clicked the analyze it. When I clicked this last time, it crashed stream. I don't think it will happen now. I think it was because I had too many Firefox tabs. And that this one just took too much memory. I still think it should be safer, you know? OBS is too unstable, really. I don't use a lot of plugins. I have like 2, right? 3, 4.
Corpos says,
Hi.
Hi. Good old memories with C in the university. Greetings from Argentina.
Oh, Argentina. Nice. So I'm in Sweden. So greetings from Sweden. Let's just click the analyze. That's the button that crashed the stream last time. Yeah, but now we don't have 50 extra tabs in Firefox. So it worked. Well, let's go to here to functions and go to main. And now we see our main is bigger than it was. It's much bigger here, right? We still have our RBP. I would like to see how the stack, what happens on the stack while I actually read this, but it's not possible here, I guess. Right? I can't do that here. Anyone who knows Skidra? I know that this was like script manager, the only play button, so I saw it when I read the menus before. Push RP, we save the old one. We copy the stack pointer to the RBP. And we copy the address of the string to RAX. And then we put this in RDI. So, I'm curious here. So I know that some things you can't put straight. So you can't put it straight from there to here. Is that it? You have to put it in the register first. Anyway, then we call puts. Come on. Puts char. So here is printf, right? But this is the formatted one. And it just replaced this one with puts. Which is interesting. Because it didn't before. Let's actually do the same as we did with the last one and put this one in. I guess I will need to click copy special, formatted code, okay, go here, make a new one, paste it here, select all, copy the classic vax, and then we can paste it here, right? So I added a bit. Another function. I see it uses puts now. Well, that's the compiler. Please explain all assembler. Sure, let's break down the assembly for the main function. So we know this by now, right? And every time we see it, it's more stuck in the memory. We save the old RBP, the base pointer for the previous stack frame. We save it. We set the base pointer to the current stack pointer, so we have the base for this one there. And load and call puts. So we get the string into REX, or rather, if I here load effective address of the string hello into REX. And this is the memory address. Yeah, I should remember the part here is actual memory. And then move. I think move is such a funny name for it, because it's not moving, right? It's copying to REX. In REX to RDI, which is the first argument to puts, according to the calling convention. Call external puts. Call the puts function to print a string hello. Yeah. The question is why? I'm curious why the compiler made this change. Set up and call add. Move the value 2 into the ESI register. The second argument to add. Move the value 1 into EDI register. So ESI and EDI. If we hop back. Here we have the arguments being loaded. And then it calls add. And add, of course, is it before? Yeah, it's just before as I wrote it in the code. So I didn't send this there too. So it does the same thing at the start of the function. Push RBP, move RBP, RSP. Save the new one. Save the old one, then override it with the saved SP instead, stack pointer. And then it does the math. Oh. Well, let's really add this function too. I should have put both there, right? It remembered as last time that I copied that last. So actually so we just have it ready. Call add, handle return from add. I want to have this up so I can see. So it's calling add, and when it returns the value of EAX will be the returned value here, right? You can also even see it putting it in here above here. And then what's this? So here we can see the hello. But what is this? Oh, it's a %d. You see? For the printf. Okay. So back. Come on, back. So this is the %d. Also it says 25H%. Okay, this is not as clear as the other thing. Into RX. RX RDI. Yeah, so I will hop back and read here. So handle the return value from add, move the return value, which is in EAX, to ESI, right? And then it's setting up for printf, and we saw that this one was the %d here. Load the effective address of the string format possibly %d. Yeah, it guesses right or similar to REX. Is a memory address where the format string is stored. Move the address of the format string to REX to the RDI register. And this, I remember the %d. It's not like I didn't think about it. It's just my brain popped it up, since I used it so many times. So, generally. So that's the kind of thing I want to have with this. That's why I'm reading it and it will just be in my brain without me having to think then after a bit. So now I haven't done a lot of C lately, so or any printf thing, but it was still there. So move the address of the format string rex to RDI, which is the first argument of printf. Yeah, it's a forced argument. I was like, is it the first? Yeah, that's the first argument. It's a format string. So set EAX to 0. This is typically used to indicate that there are no floating point arguments to printf. Okay. And is part of the x86 calling convention for variadic functions. Never heard variadic. Call external printf. Call printf format function. Function epilogue. So set the return value of main to 0, indicated successful execution. Restore the previous base pointer. Return from the function. Oh gosh, I'm still sweaty. But I'm having fun. So we didn't send it out of the function, so that's why I copied it. So this is the add function. So since we already have what we wanted to do, right? It's just continuing with the same thing. Let's break down the assembly code. Function prolog. It does the same thing. We just skip it. Save arguments to the stack. And this is more interesting because store the value of the first argument. Because I just did it in return statement, the addition. So I'm curious how it does it here. Store the value of the first argument in the EDI register into the stack location local C at RBP 0XC. Well, I guess I shouldn't read that. Store the value of the second argument in the ESI register into the stack location. Load arguments from stack. Load the value into the EDX register. Yeah, I know what my question for ChatGPT was. Why? It will be why. Into the EAX register. Perform addition. Add EAX, EDX. Add the values in the EAX and EDX register and store the result in EAX. Since EAX is used for return value, the result of the addition will be returned. And then it just ends it. Pops the RBP returns. And responding C code. Yes, that's what I wrote. You hit the free plan limit for GPT-40. So we've been asking a few questions now, right? That's funny to ask the same question again. Also, I did at least 2 misses, right? Pasting a lot of stuff and mistyping. Or rather, I pasted and clicked enter before even seeing that it didn't paste the stuff. So, why put the values, the arguments in stack vars and then move them again to EDX and EAX. So I'm thinking there are limitations, right? Let's I'll actually TTS this. Save my voice a bit. I think this is a good, hopefully correct one.
The use of stack variables in the add function, even though the arguments are already available in registers, can seem redundant. However, there are several reasons this might be done in practice. Reasons for using stack variables. Function calling conventions. Calling convention, the assembly code you provided adheres to the x86-64 calling convention, where function arguments are typically passed in registers, EDI, ESI, etc. However, functions often use stack variables to manage data, especially when more complex operations are involved or when adhering to certain coding practices. Debugging and symbolic debugging. Debugging, using stack variables allows the compiler or assembly code to maintain a clear mapping of variables and their locations in memory, which can aid in debugging. It provides a straightforward way to track and manage the variables used within a function. Alignment and optimization. Alignment, storing variables on the stack can help ensure proper alignment of data, which may be required for certain optimizations or hardware requirements. Optimization, some compilers or code generation tools might generate stack-based code for optimization purposes, such as optimizing register usage or ensuring consistent data handling across function calls. Code maintainability and consistency. Code consistency, using stack variables provides consistency in how data is accessed and manipulated, especially in more complex functions. It can simplify the code structure and make it easier to maintain, particularly in functions that perform more extensive operations or require complex manipulations. Future expansion and function complexity. Complex functions, in more complex functions, you may need to save additional state, handle local variables, or perform operations where stack-based storage is necessary. Even though the add function here is simple, practice of using stack variables is a general approach that scales with function complexity. Detailed explanation of the process. Here's a step-by-step explanation of why and how this might be done. Initial state. Arguments are passed in EDI, for the first argument, and ESI, for the second argument. Storing arguments. MOV word ptr_rbp plus local _c, EDI, store the value of the first argument into a stack variable at rbp, 0xc. MOV word ptr_rbp plus local _10, ESI, store the value of the second argument into a stack variable at rbp, 0x10. Accessing stack variables. MOV edx, word ptr_rbp plus local _c, load the first argument from the stack into edx. MOV eax, word ptr_rbp plus local _10, load the second argument from the stack into eax. Performing operation. Add eax, edx, add the values in eax and edx, with the result stored in eax. Returning result. Pop rbp and ret, clean up the stack frame and return, with the result in eax. Example scenario. Consider a more complex function where you might need to use additional temporary variables or manage data in a more intricate way. In such cases, using stack variables simplifies the management of local data and ensures that the function behaves predictably regardless of the complexity of its operations. In conclusion, while the use of stack variables in a simple function like add may appear unnecessary, it is often a result of general coding practices or conventions that ensure code maintainability and clarity, especially as functions grow in complexity.
I was just checking. Sorry, it was very slow. Yeah. So maybe I should have aborted the TTS there. Yeah, so is there anything that's not clear for anyone? So the only thing I was like, it didn't give us a good answer to this. It puts these, it's getting the arguments here in ESI and EDI, and then it starts the calls to function here. Oh gosh. And when it's in here, it puts them in these local variables here. I shouldn't. What is it? 17:52. Yeah, so it's probably just time for me to stop streaming. I'm feeling I don't want to like overdo it with my voice being like. I guess I've got a bit of a cold, but it's not that I didn't go to work or anything like that. But I didn't bike today or yesterday. So, do we want to do something else? I can hear myself, and my voice is starting to hurt too, so. It's annoying. I can also hear my kids. So I should probably spend some time with them too. Yeah, anyway, it uses a variable as a reason. I know that in some times it's like limitations on what you can do. You can only move one thing to one thing. I don't know if you can actually move from. But here we are moving from one register to another, so you know. Why use this in between? Right, I think it's time to test that, right? So, we have all of this in our file here, right? And so I always forget that this is a recent one. Why does this exist? Can I remove it? Remove? No. So I'm thinking here we have a basic assembler program example, and let's save this as hello2.c, and then we change it to what we had before. So we have the basic one too. It was just this, right? And we save this as hello.c. There. And here we have, let's skip this one for now. We don't need that one right now. We want to make a new ASM file. So save this as hello2.as, and we have to change a lot to make it this style, but what? I'm thinking I'll copy this and close this file, and at the top of this one we will put this, and then we will edit it to Let's do hello. Right. There are so many comments in this too. Anyway, I'm just generally don't know, but right. Basic ASM function. So now we're going to add a function, not making an add function. Well, how to write a function. Yeah, I was thinking of doing add colon, but let's see. Func. Yeah. So it's just that. So add. No, I'm typing in the wrong place. Add colon. And here we're going to add the add stuff. And we're not going to use these. So let's delete this. And we need to remove all the addresses in machine code. So these things we're going to change, and this is the test. So if we just do edx here instead, and we do copying 3 letters. EAX here, and then we delete these 2 lines, right? And here it's the add. Also, I'm thinking EAX is reasonable, right, to use. But why do this one? Couldn't we just do EDI instead? Let's do this first. And let's do remove to test later, right? And this is the old one. Yeah, we're going to use write syscall and number 1, and use a message as the buffer, and the message is this. So what does this mean? You know, I changed this. let's check it out with this. What is the comma 0xa? Oh, it's a new line. Okay. Oh. So I didn't even want a new line. So I would have thought 2 seconds more. I would have realized A is 10, right? But this is interesting too. I noticed the dollar minus current address. Cool. So current address minus this address that was just above. Alright, so I understand what that is too. Nice. So this is still correct because it checks the difference between here and here. And then we have the main one we need to fix too. So first of all, this is okay. What happened? I think I clicked Control forward. No? I don't know what I did by mistake. What did I click? Oh, whatever. It would have been fun to be able to redo it in Control. So here, we're similar here, right? So we're going to use the right syscall. And what we do here is actually to run external functions instead. And here we use a syscall. So let's not use a syscall. Let's see if we can run the external one. Though we would have to learn how to do that too. We still need printf for the other one. But for the hello we could use this. Right, so this bit here is just the hello, and that's the same. And then we were going to call that. So let's get rid of a bit more here. Rx hello external puts. You can use both. I'm just reading it. Lia move call. And then it's putting let's actually right, so exiting the program. EAX, they have actually one, and they pop RBP red because this is a part of a more complicated thing, right? So let's just delete these that are after the call to printf, right? And I'm curious how we're supposed to call printf, because I don't think that's how. That's just how we get to know it in Ghidra. So there. So let's paste it over here. And of course we need to remove this again. Trying to find the most efficient way. Right, first of all, we need more. Oh, I was just doing this last time. The string. We need the string too. And we need to rename, or what am I saying? Delete these things. And what does it say 25H for? So I don't believe this will work. So I'm curious to see what the assembler will say. Assuming I remember how to do it. So we move 2 and 1 to our they are the argument for add. We're calling add is run. After that we put the response in ESI because we're running another function, so we want it there. That's the first argument. Then we put the string that we don't have, so we're going to have to add a string here too. And this is a section data that we remember from Gidra there, and the ChatGPT read for us about this. So let's call this one format colon. Should I do db again there as the previous one and do %d, and we don't need more things there, right? I don't know yet if we were to ever need the length of it or anything. We're not supposed to print it. It's just a format string for printf. So now we have what to do put here. This is now format, but how did it do it here? Message, just put it there. Though these don't have spaces. Oh, how long since I used the insert button. That's a messy thing, right? So should we remove these spaces? I don't like them. I just added them because they're here, right? That's prettier, don't you think? And also, why are there double spaces here? So I'm assuming this won't work. I saved that. There. So now we have an ASM file there too. Let's actually move hello 2.asm 2.asm, right? And let's cd to ./as. So this is where we have our hello files. Oh, right. Yeah, we didn't have a hello to here before, right? So I don't think I have anything in my history except for us editing the files. Quick Google here. That's all I did. So, typing in the wrong place. So, NASM is something we have. And how does it work? So, I don't even know if this is what I used before. And we know that our ASP file is bad, but I want to see what it will tell us. NASM options file name. Oh, output file. So it looks very similar to JCC. NASM. And I'm just testing. So hello, right? Hello dude.asm. Oh, this is why I wanted it in this folder, so we don't overwrite the other hello too. That's why I moved it. And there's a syntax error, which we knew on line 31. So I don't know how to do this, so let's actually put this in ChatGPT again. Here, so I'm trying to make an ASM file to, well, but I don't know how to call an external function. And then we don't say I have this blah blah blah. It will understand that this is what we got so far, right? Or it won't understand the thing. To call an external function in Assemblyify, you need to set up a function call properly and ensure that the external function is linked correctly during assembly and linking. Since you're using x86 assembly, you want to call the printf function from C standard library. Here's how you can modify your assembly file. So we have an extern here. So let's go right here, right ahead and edit the file. So hello asm, global start and extern. Printf. Here, which is obvious, we don't need a comment for that. Then we have this. Ah, look, it made comments for us. That's cute. It's made comments for us. It did remove my comment though, which is not nice. So, it's made comments. No, it's changed these comments. It didn't like my comments. Syscall number for syswrite, it says there. File descriptor for std out. Might be better ones. Pointer to message, and then the length of message, and invoke syscall. We're running the syscall. Then call the add function. It's split it up here after this. Prepare for printf, it's put in here. So it has ESI, let's see, ESI EAX, it doesn't have this at all. It has RDI REX. Let's hop over. So it's totally after the, no, it has this bit here. EDI, it has EDI, EAX, REX format, and this is squares. I don't think we needed that for message. Why would you need it here? I don't know why. Whatever. Let's skip it for now. Why would it be different? And so it puts the address into REX with LEA, and then it does REX RSI. Call printf. REX to RDI. Printf format string. It has put in REX. No floating point arguments. EAX. Yeah, so we have this too, although only our is 0x0. Yes? Kids knocking. I'll be right back. Jag är snart klar.
VR Mechatronics says, "Hello, how is going today?"
Jag ska bara göra en sak till så ska jag sluta sen. Ja, jag går och ser om jag kan göra klart det sista lite snabbt, okej? So I need to make dinner for my kids soon. Hi, VR. Welcome in. So I have some code. I asked for some help from ChatGPT here to get an external call, and I'm just comparing what it has changed here. So we don't want to do more. Right, so let's start with just doing one thing. We added external printf, and we're removing external here. Just doing cold printf, right? Because that's cold printf, what it does here. And let's see if it added something. No, it didn't change the data section. Just remove the indentation. So, whatever changes it made, I'm just skipping. For some reason, message it didn't change, but it wanted square parentheses around here. Also, let's so my old one didn't have tabs in between here, and the new ones have. These are from right. So I don't know. Are tabs better? This is annoying. This is annoying. Is this prettier? And this is all spaces. Now it's a tab in there. I don't really like tabs, to be honest. I don't. I want it all to be spaces. There might be a setting in the editor to replace them, so I'm just saving this now, and we're going to see if it works now. It's still got the same error. But I don't know if I'm doing this correctly, you know. No, right, I need to do something when I need to add it to the... So I'm having to do... I'm just scroll down here, because I assumed that it would add the linking.
Should be always only one white character, I think.
What? I don't know what you mean for one white character. Let's change. Assemble the code right, so we do it F now. Okay. So F. But we don't want, we want a 64-bit. So we change that. And we test this. And it still says error. So I'm going to copy this. To ChatGPT. And I'm going to copy what I decided to test here, right? So I didn't do as it wanted. You encounter an error. It might be related to the use of int 0x80 syscall instruction. In fact, you're working in a 64-bit since you're using. Okay. System calling conventions are different from 32-bit environments.
Because the IDE always skips the extra whitespace characters than one when compiling.
Oh, I'm not talking about for the compiler. I was just talking about pretty. Nice to use. So the compiler in assembler and C, they won't care, right? So whitespace is whitespace. But I guess that's what you said, right? Or they should always only be one. No, it doesn't care. So let's see here. So as you can see, also these are different lengths, so it will always be different length there anyway. So what did it? Now it opened. Oh, put the data at the top. So now it's using 60. System calls a root as called function instead of int 80. RAX contains the syscall number. So the old one did 32-bit. I don't think it's right. I think it's wrong. So let's test syscall. Let's compare the previous ones. REX 0. So it would be nice if it didn't change a million things, right? So now I'm in the right place. Syscall. So apparently it's changed this to REX. I don't like changing a lot when I don't know why. RDE. And then it's setting this to RSI. So I don't like this. I'm lost now. RDX. Syscall. So I'm leaving the rest as it is. We're saving this. And we're testing this again. And I don't think that's it, you know. So we could make a new file with its things. So I'm undoing this. So I think it's back. Let's first of all try this 32, right? It's still the same, right? So then we can prove to it that it's the same with 32-bit. Yeah, so this is where I don't think this will help, you know. We will have to debug the normal way by actually removing stuff. So first of all, we don't need it right hello. That's just an extra bit, so we're commenting that. First of all, also this needs to be uncommented since we're removing this. So all of this is just extra stuff. So if this was what was causing the problem, it shouldn't give us any problems, and it's still doing that. Hello.
Streamar eller?
Yes.
Och Linus står ute och cyklar.
Vad kul gubben. Gör det. So my hubby and kid is going biking. Jag kommer göra mat jättesnart till lavan. So it's a really warm day too. I don't look forward to turning on the stove and stuff and making food. So I'm skipping ChatGPT, and we need to learn more things, right? So we hopped from a basic thing to a more advanced thing. and without actually looking at learning stuff. So calling printf x64 asm, right? And let's do there. So we have help at once here, right? I'm trying to print it from a string, and they just misspelled it there. Getting an error, cannot find else. Let's see what they're doing. So section data, they have a string. DB, the number is person D, and then they have.
I wish I knew English that well. Frown, frown.
That well? How well? I don't know. If you were saying them saying they wrote the command Nassen, so it wasn't real English. It was this. Let's see what people answer here. So, does this answer your question? I'm trying to write a simple hello world program with nothing, putting a variable into the stack and then calling printf. Import extern printf. So this bit ChatGPT got right? And I didn't think it would make such a basic error, maybe, but section data, MSG, ours is message. They do hello people, we had a hello. And they do the same with length of the message. Section text, global start. We have global start before the section text. I don't think it's supposed to be in the text, is it? So push MSG. Why? Assembling the program with muscle works. Also, they have the commas in the string. I don't think. No, that was the last one. This one. Let's do this one. I'm just missing the other arguments, right? I want the formatted one. Assembling the program with NASA works fine, but when I try to link it with ID, it throws an error. So I can't assemble my program, but here we can see a simple one. Hello world loading function start. Undefined reference to printf. Seems extern does not import printf. What am I doing wrong? It's literally my first assembler program. Please use simple words. So they're doing the FL64 here that we want to do. And then they do LD. Yeah, because ChatGPT was using GCC to link it. It feels a bit off, right? Extern just tells assembler that you will provide the definition of a given symbol externally. You still need to provide it. That is link with libc. If you wish to use C functions, it is recommended to use main as the entry point and not start. Okay. And use GCC to link. Okay, so we should use main as our start. So the main here instead. So this is just a label, right? So it doesn't matter what it actually is. So I'm fine with that. And use GCC to link since it is C. So then ChatGPT was not off. Also, do not use direct system call to exit. Instead, return from main or call exit. Make sure you're creating a 32-bit program. Why? Why? You can't tell someone to make a 32-bit program if they want to make a 64-bit program. That's stupid. Hey, I'm not sure that made a lot of sense with someone who knows that what they're really doing, but I don't. How do I use main as an entry point? I tried that and I get an error that start isn't used as an entry point. Why should I do so? Don't tell NASP. How do I tell NASP to use GCC? Yeah, why is it important to do 32-bit, not 64? Even though I'm an x86. Does the CLIP use 32 bits? I have so many questions, and thanks for your efforts, but it didn't really help. Maybe a duplicate. Well, why would that be a duplicate if you want 64-bit? LD has an L option that takes library name. C is the name of the C library. LFoo links libfoo, so C links libc. That really do what Fuss said. Fuss. So there's no fuss in this so far. 2 more comments. Yeah, this was really kind of not useful. Those were just comments. Let's look at an answer. Only that provides printf. And they're also doing 32. The bubble will not work, but how GCC will try to find additional code found in CRT1. .o contains start to start the C runtime and then invoke main. The easiest fix is to write a main method instead, and this is what we just changed it ours to. Yeah, so looking at someone who's making their first test as a program, it's not the best code to look at, right? But they're using push message as he does. Here, I'm not concerned, so I can easily test that, but I think that's what you need. Yeah, so let's just skip this. And this is not interesting. Let's skip this. And I'm thinking it's better to do an actual tutorial. So we had one the other day that was suggested. So I think that tomorrow I will do it not from the backwards way of taking Ghidra code and trying to make it assembler, right? But actually the other way around, starting and building it from scratch, right? And Right. There will be lots of other things than people asking for help. That's better to actually read than to look at code that's bad and try and fix your own code with bad code. Right. And ChatGPT, we don't trust to have all the answers. It can help sometimes, but not in this case. Right. Now we can close this one. We have an open one. The box is of course expired hours ago. Because I haven't really... Yeah, I need to know more before I do. But this is what we're going for later. So I'm thinking... I did put in my notes. Where's the notes? They're off. Because stuff crashed. So we have the ASMR. I had lots of links. So this is a lesson exercises. So we're going to do this tomorrow. We can look at the hello world there first. And they're doing it the way I did it, right? They're doing it the right way I did it. It's just different in lots of ways with the order. So will it call external files? It will definitely do that. Yeah, we'll do this tomorrow. We'll see how far we get tomorrow on this. So tomorrow it's Asm Tutor. I know that this is kind of simple, but why not start here, right? Proper program exit. So why did I stop my program with? Run the syscall 0 evac. Yeah, that's what I do. So these are like, now we're up to my old hello program. So what did it say? There's also text I want to read. So now I'm just curious to see when we get an extern in here. Externals. So making several files. Yeah. They're including the other summer file. It's so annoying to have to scroll though. And null terminating bytes, line feeds, parsing arguments, user input. So let's click at something like this. I print lf. Include functions as. Because I was thinking, how are they doing outputting numbers? Functions as. Oh, they're in one. Why was I doing that scrolling? So, let's just do search for extern here. External include files. But this was the one with their own file. That's not what we're after. So many mentions. Also, it's not there. That kinda broke that idea, right? If we're not even learning the thing I want to learn in this course, then it's useless, unfortunately. So let's check all my links I made here. Short guide. So we don't need to call printf, it's just a very nice function that was, since I did it C and went backwards, you know? That's what it did. So, no extern in here. Nothing in there. Yeah, so I need to go and make some food, so we'll have to continue tomorrow. And it's sad that I don't get to finish it though, whatever. So we might start with this anyway, but it's very basic, you know. We might start with it anyway though. I prefer like searching for the answer, and we could probably just debug this instead. And debug this, we could also just do such a basic thing to start an actual code editor instead of mousepad, right? We can start code, and we can just like open the file here. Is to yeah, right, this is the wrong path. Did I not make any of the changes I made because I compiled on the wrong path or assembled? So let's open a new file here, because I might have just messed up. Home, programming, assembler 2, and it will probably, if I control S or whatever, will it tell me, hello, you need some stuff here. Why don't you have a assembler? Why don't you have any assembler stuff in there? So what if we install this one? 1,000 people, that's not a lot. Whatever. So now we have colors in it. We could go awesome, right? Whatever. We don't have to do anything at all more today because we're not doing anything more today, unfortunately. It is 18, it's almost 19. My kids need more food than they already got, so my hubby is home now. Let's open my browser. Let's see who's online. Oh my, we have a lot of people on today. Well, this is not really people, but this is just watching them do like nothing, sit by the computers. I guess we're going to Pebble. So there.
Execute Docker.
And let's mute him, and I'll just. So, let's see how many people we have. So, thank you everybody for being here. I will continue tomorrow, and I think that I haven't decided. Debugging is like better, right? And we can also see how odd the code looks here with all the tabs and not tabs, and you know, it's not that it's not pretty. But we can just comment lots of stuff and go from there. So, better editor, another one. Where a tab is actually not a tab, right? So if I put a tab here, it's a tab. Okay, I want it to be spaces, but I can figure that. So thank you very much for being here, and YouTube people, you can hop over to just click the link I sent. Yeah. And it's still 30 degrees in here, Celsius.
Bin bash into a file called fullcheckup.sh.